What's up, Calc? Coming at you live with a brand new video on math. Today we're going to be looking at 5.3 homework, the 5.3 homework number 2 actually. So if you want to follow along, we're just trying to find increasing, decreasing intervals for the function g of x equaling x squared root 9 minus x squared. I didn't assign this specific one because I knew it'd be a little bit tedious per se, but may as well go through it. And of course, there's going to be two things throughout the video, two questions, so follow along for those. For increasing, decreasing intervals, all you're simply looking at is to find where your derivative equals 0. So let's take the derivative. Yippee. So it's going to be a mixture of rules. So let's see. Let's go over here to do it. Get more board space, be conservative with it. Then g prime of x is equal to the derivative of the first. So this is product rule because you got two things getting multiplied together. So the derivative of the first, which is x, leave the second alone. So 9 minus x squared gets copied and pasted. And then plus derivative of the second, leave the first alone. Now here's where things get a little bit tricky. And also, I'm going to move over a little bit because I want to use this space for the sign chart. So g prime of x is equal to square root of 9 minus x squared plus, then leave the first alone, which is x. And then you power rule this. So this is all to the 1/2 power. So you got 1/2. And then copy and paste the inside, 9 minus x squared to the negative 1/2 times the derivative of the inside being negative 2x. Okay. Following along. Great. So now we just clean it up a little bit. So leave this thing alone. So 9 square root of 9 minus x squared. And then plus, or actually minus, because you got that minus right there. So you got x times x giving you x squared. So minus x squared. 2 times a half cancel. And then this is all negative 1/2. So square root on the bottom, essentially. And now we're going to be shoestringing because since we're doing a sign chart, technically we're doing a rational inequality. So put this over 1 and shoestring to the top. So you got square root of 9 minus x squared is the same thing. So like square roots pretty much cancel. So now I got 9 minus x squared. Minus, and then x squared times 1. All over 9 minus x squared square rooted times 1. All right. Then g prime equals. And then finally, let's actually rewrite it up here in a nice, clean little fashion. Yay, great. So we're going to use purple here, and hopefully it shows up pretty well, even though this is almost not purple chalk here, so I'm going to have to reload it soon. So you got g prime. Oh, it comes up beautifully. Okay, great. 9 minus 2x squared divided by the square root 9 minus x squared. All right, great. So now we set up our intervals here. Now, the intervals would be the negative infinity to your first critical number, but there's a thing here, small catch. Let's look at the original function and see if we have any domain restrictions, by the way. So while we're doing that, your first AMI question is, what do you do on your AMI days? What fun activities do you have? Do you have some sort of special show you watch? A special food you eat? A lot of homework? Leave it down in the not comments, in the Google form down below. Duh. So that's AMI question 1. All right. So let's look at this domain restriction. Domain, any x values we can't plug in. Now, one of the rules of math we can't break with domains is that you can't divide by 0, and you can't have negatives in the square root if you're dealing with the real point. We're not dividing anything in the original functions, but we do have a square root. So we have to figure out where that square root, or where you might have negatives in the square root, or what x values could possibly plug in. Now, you could easily just, because the outside doesn't really matter for domain restrictions because it's just x. So, you can factor 3 minus x, 3 plus x, and then also sign chart if you really want to the inside. But you can also just plug in values in your head. For example, 9 minus a big number might be negative, and you can't have negatives in the square root. Oh, no. So you simply see that your domain for this function is actually -3 to 3 bracket. That's the domain, actually, of that original function. Not the derivative, but the original. So that being said, let's set up our intervals now for the sign checking. Cool. So now I'm over here. So you got your out order point, which is -3. And also note that it's an open parenthesis here, because when you're dealing with increasing, decreasing intervals, you have to use open intervals because that's just the definition. To your first crit value. Now, the same critical numbers. So critical numbers are where the bottom equals 0 for the derivative, so where it's undefined, or where it's equal to 0. So the bottom equaling 0, that's clearly 3 and -3, because we literally just saw that right there. And those aren't really helpful here to find those critical numbers, though they are. We still don't include them because when you're doing your increasing, decreasing intervals, the endpoints really don't take much into consideration there. And then let's look at the top. So let's set that equal to 0. So scratch work over here. So you got 9 minus 2x squared equals 0. So you got 9 is equal to 2x squared. Let's divide by 2. So you got 9 over 2 is equal to x squared. So x would be plus or minus the square root of 9 over 2, which we can write as 3 over square root 2. The square root of 9 is 3, and blah, blah, blah. So -3 to root 2. Okay. And then you got your -3 to root 2 over root 2 to 3 over root 2 positive. And then that to +3. Cool. So those are your x values. And then let's look at g prime, not f. And plug in numbers in the intervals. Now, Mazzola, if this was a non-calculator thing, how would I be expected to know what -3 over square root 2 is, you may ask? Well, guesstimate. You know that 3 is 3, right? Square root of 2 is somewhere between 1 and 2 because square root of 4 is 2. And square root of 1 is 1, so square root of 2 is somewhere in between there. So that means that 3 divided by 1 point something is probably less than 2. So therefore, you can plug in some -2 or something. So let's plug in -2 into the thing. So you got 9 minus 2 times -2 is square root of 4, so 8. So you got 1 divided by, and then 9 minus 4 is still a positive number. So you got positive divided by positive. So you have positive. Yay. -3 over root 2 to 3 root 2. There's obviously 0 in between there. So you got 9 minus 0 is positive, and then square root of 9. Hmm. 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 Something's fishy going on here, and I can't really tell what it is either. Shoot. All right, figure it out. Sorry about that little delay. So what ends up happening? Okay, so I made a silly goose mistake. 9 over 2 is like 4.5, right? And the square root of 2 or square root of 4 is 2. So this is literally right above 2, meaning that whenever you plug these in, plug in specifically that, you actually end up getting a negative value. And the bottom is still positive. So, because we can really just work with positive values. And we already know that based on the domain restriction. So then we end up getting a negative. Yay! And then it's a copy and paste of this too. So, yay. Now, increasing, decreasing intervals. Increasing is where your derivative equals 0. Or positive, not at. Positive, duh. So then you end up getting the inside. So that's going to be your answer there. Decreasing would be these two other ones. So writing those out in open interval notation. Yeah. In addition, you also know that since you're going from a negative derivative to a positive, at negative x equals negative 3 over root 2, you're going from decreasing to increasing. So you have a local min right here. You'll have increasing to decreasing. So you'll have a local max there. But your second question for your AMI form is, if you're looking for the absolute min and absolute max, what would be your next steps? Cool. That's going to be Google form question number 2. Anyway, email me if you have any questions. Yay. Cool.